Hello everyone, it is nice to be virtually here, and I will talk about data exploration and how with the use of intelligent data exploration tools we can democratize data access. I'm Koutrika. I'm a research director at Athena Research Center in Greece. Hello from Greece. My interests lie on the intersection of databases, information retrieval and machine learning, and in particular I'm interested in data exploration and recommendation systems among other things. So nowadays, we generate a lot of data that comes from users, from systems, from sensors, and all these different data sets contain information about scientific experiments, educational data, health data, and so forth. And they are actually used by many different types of users that are looking for insights, pattern, information, etc. For example, scientists performing experiments or consumers looking for information or analysts looking for insights inside the data. Hence, essentially, the benefit of data exploration has become increasingly more prominent. However, at this point, let's just ask ourselves, how much data do we really create? And there are many different numbers out there. I just want to show three examples to get an idea of how much data we really create. So the Sloan Digital Sky Survey, or SDSS, is a multispectral imaging and spectroscopic survey of the sky that is using a telescope that is located in New Mexico, United States. It scans the sky and data collection has started in 2000. Every night, the telescope produces 200 gigabytes of data. Another example is Visa. It has a huge network of banks and organizations that connect to this network, and only in Q4 in 2016 and in the US, we recorded 9 million transactions. Just to get an idea of how large the dataset they collect is, the flagship data center has over 300 servers, 300 switches, and all these are connected by 3,000 miles of cable. And as a last example, social data, we all generate so much data on social media. For example, more than 300 million photos get uploaded per day on Facebook, not to mention that almost 500,000 comments are posted every minute. These make around 2.5 quintillion bytes of data that are created every day. At this moment, let's now think and take a look at the data exploration tools that we have at our disposal. And I would like to examine them using three dimensions. First of all, how a user interacts with the system. Here, basically, we have two options. We can use a form-based interface like the one that you see here, where the user would click the options that the interface offers, and based on these options, some results would be offered. Now, of course, this offers certain query capabilities for the user and essentially very limited exploration capabilities. Now, if someone wants to be able to ask any type of query, then they should use a low-level query interface, essentially meaning that they should know SQL or some other query or programming language. They should know exactly how the data is stored in the database, meaning the data schema, and they should have more or less a well-formed information need, which could be expressed in SQL, for example. So all these limitations come with the input. Now let's take a look at the output. Now the output, basically the system in response to a user query would generate data in a tabular form. And if we want to make this data more beautiful, some predefined reports and dashboards would show them in some visualized way through graphs. Now, of course, here we also have several limitations. For example, there is no interpretation of the results. We don't see any explanation why we see these results, why the system is showing these graphs and so forth. As a result, generally, a user does not have a clue regarding how to proceed next. So what would be the next query? What would be the next part of the dataset that the user would like to explore? Last but not least, when it comes to the data that these exploration tools allow us to see, they basically assume that we have a static no schema. New data may come in, new records may come in, but the schema is predefined, which means that the users basically do not have a good option to find, link, and query new related sources. So essentially, on one hand, we have a lot of data, but data volume and complexity, as well as the limitations of the tools that we have at our disposal, make it very difficult to leverage data. And essentially, most of this data remains basically unused. Again, here there are many different numbers. I just want to share with you a few that kind of illustrate how bad essentially the situation looks like. So based on the Gartner report, 97% of data in organizations is unused, and 90% of unstructured data, otherwise called dark data, is never analyzed. And similar facts also pertain to how much we use the servers that we have and their computing power. So essentially, the question that arises is how can we better explore and leverage our data? And today I would like to share the vision of human-like data exploration and how we work towards a system that looks more like an intelligent data assistant, meaning that it can converse with a user in a more natural bilateral interaction. It can actively guide the user, offering explanations and suggestions. It can keep track of the context and adapt to the context as it needs, and also it can keep learning from the users, from the queries, and from the data and becoming better and better. Now, that reminds us of chatbots. A chatbot essentially is a tool that mimics conversation with people. It uses artificial intelligence techniques and it lives on consumer messaging platforms as a means for consumers to talk with the companies. Now, of course, chatbots have certain functionality and certain limitations. They encourage only canned predefined types of interactions. And as a result of it, they can answer very simple questions, unambiguous, like, for example, where can I order pizza? Or what is the weather forecast today? They cannot answer random or complex queries over data repositories, which is what we want. So, towards human like data exploration, there are a lot of challenges and there are a lot of things that we can actually do. And today, I would like to share some of these possibilities based on the work that we are doing. So the first thing in doing the system, in going towards more human-like data exploration is, of course, to enable a natural language interface to the data. So on the right side here, we have the system and a very simple database, essentially one table that stores information about players. Now the user asks the query in natural language, and the system can actually understand this query, translate it to the SQL query that can be executed over the data, and return the results to the user. Of course, we want the system to be able to understand even more complex queries. So here in this example, the database has information about departments, locations, stores, employees, dependents, and so forth. And the user is asking, what is the benefit of workforce reduction in departments that have more than two locations and for employees that have no dependents? And we see here that the SQL that the system generates is much more complicated. The user would never be able to come up with such a complex query, but all this is hidden from the user who will just see the results that he likes. At a very high level, how a system like this looks like, it has two major components. One that has to do with understanding the natural language query that comes from the user, and essentially that means trying to find what elements of the query map to database elements like tables and values, and also try to understand how these elements connect through the query logic. And this gives us possible interpretations for what the user is actually meaning. Using these interpretations, the system then will try to actually generate a query, translate them essentially to SQL in our particular example, and these SQL queries will be executed over the data and bring back the results that the user would like to see. Of course, as I said, this is a very simplified system architecture, and there are multiple different components that bring this idea in reality. And I would like to show that through an example. So here we start with a query in natural language that I asked for movies that have the same director as the movie Revolutionary Road. And here we're using a syntactic parser to understand the syntax of this query. And the syntactic parser, for example, Stanford parser, will generate a tree like this one here that essentially captures the elements of the query, of the sentence, and how this connects syntactically through the sentence. Now, the node mapper here will try to map these elements into elements in the database. For example, Revolutionary Road is found to be the title of a movie, and the word movies is found to map to a movie table inside the database. Now, taking this information, what happens next is to transform this tree to something like this here, a tree that tells us again how these database elements connect through the query logic. So here, essentially, this tree says that we want to return movies. This movie should have the same director as the director of the movie Revolutionary Road. And now the final component in this architecture is an SQL generator that takes this tree here and generates all the complex SQL that needs to be executed in order to bring back the results that match this query. Now, there are many challenges in actually achieving a natural language interface to data. I will mention just a few because there are really many. For example, polysemy, where a single word can have multiple meanings, or the same sentence can have multiple interpretations. For example, find all German movie directors. This could mean find directors that have directed German movies, or directors from Germany that have directed movies. There are also cases of paraphrasing. We say, how many people live in Texas? And this refers to the population column of a data, which is very difficult to actually map. Not to mention, of course, challenges that come from SQL and from how the data is actually stored in the database. SQL is a very strict structured language, and something that we may express very naturally and in a very simple way in natural language may have a very convoluted SQL query. For example, when we say return the movie with the best rating, the underlying SQL query that needs to be executed is what we call a nested query, and is of course a much more complex query than what we see in natural language. Now, moving forward, we actually want to go beyond query answering. In a query answering paradigm, we assume that the user asks questions, the system takes the question, executes it, and returns the results. Now we want to allow a conversational interface, meaning that the system now can ask a question back to the user, and the system can also provide explanations of results that the user sees, of choices that the system has performed. And I want to discuss a little bit more how the system can ask questions back to the user, essentially how the system can ask clarifications. So here we see the user asking the query, show me comedies by Woody Allen. Now the system understands two possible interpretations that we see here. The red interpretation essentially understands that Woody Allen may be an actor, while the blue interpretation understands that Woody Allen may be a director. So the system now sees these two possible interpretations and how they differ from one another, and asks the user in natural language, do you mean the director or the actor Woody Allen? The user can respond, and the system can take the clarification into account to execute the right question. In this particular example, the user is interested in the director Woody Allen. Now, how do we achieve this? Just a glimpse of how this would work without going into much details. So assume that we have a query. We want to be able to map this query to a graph that captures all the elements inside the query and how these connect to each other. Having the query graph, we also have together annotations and templates. An annotation, for example, will tell us how a particular data element should be described in natural language. And here we see, for example, that the relation actor should be read as actors, and an attribute F name should be read as first name, and so forth. And we also have templates. Templates tells us how to connect these elements, these annotations, and how to form bigger sentences. This template-based synthesis is a way of generating natural language explanations over graphs. And again, to make things a little bit more simpler, let's see an example. So here we have an SQL query, and this query talks about actors, movies, and cast. We want to see the name of the actor for movies that were released in 2010. Now, the query graph oversimplified would look like this. So in green, we have all the relations that participate in this query. In blue, we have the condition. We're interested in movies released in 2010. And in orange, it is information that we want to see, the name of the actors. Now, the corresponding templates that we have at our disposal go like this. So, for example, the green template tells us how to read the green part of the query. So we will take the label of the actors, the label of the movies, connect them with the string that play in, and that would give us a sentence. Similarly, we treat the other parts of the query, and with this, we could generate a natural language explanation that would look like this. What is the name of the actors that play in movies in 2010? Now, the third thing that we want to do towards human-like data exploration is to make the system be even more active than that. We want the system to be able to guide the user, what type of queries he needs to execute, what type of options the user has at their disposal, and so forth. Because most of the times when the user comes to a data set that is usually big and complex, they don't know exactly where to start from and how to proceed in order to find interesting data. Now, essentially here, we distinguish two different settings. In what we call cold start setting, essentially the user has not performed any search, but tries to understand what type of things could be found in this dataset. In this particular case, we would like to be able to show a set of starter queries that the user could use to understand what type of data we have in this dataset, or some of the possible queries that could be executed. Essentially provide some starting point for the user. Now, in a warm start situation, the user starts asking questions, and at each step, we also want to be able to provide some suggestions on the questions, on possible next questions that the user could ask. And let us show an example of the second case. So, how we could show next queries for a user. Let's assume that the user has submitted a query, and the system executed the query and has returned all these results that we see here. Now, of course, this is a very complex and large data set, and the user has no clue how to proceed next. So what the system could do is first to try and find attributes within these results that are correlated. In this particular case, we have the blue set of attributes and the red and the green set of attributes. As an example of correlated attributes, let's assume that we have results that describe patients. A correlated set of attributes could be the weight and the age of a patient. Now, for each attribute group, we take the rows as they are described by the attributes within the group, and we cluster them. So, continuing the example with the patients, we could cluster the patients based on their age and weight into different clusters. Each of these clusters now essentially are described by potential SQL query, and these queries now become the queries that we could recommend to the users. All these ideas are actually researched and developed through our European project called INOD. The logo, the motto of the project is helping humans talk to their databases. We are working with three big use cases on astrophysics biological data and policy making, each one of them having different data sets with different characteristics and different requirements, but all of them have one unified need, that they need data exploration tools that allow them to actually go inside the data, look the data in an easier and friendlier way. And I would like to finish my talk with a question. The question is, we don't care about how much data we really create. The question is how much data we can really explore. Thank you very much for your attention.